Okay, Unit 1, Objective 2, we are looking at graphing systems of inequalities. In this lesson, we are going to be drawing on different pieces of information that you've obtained over the last several years of mathematics. Going back to Math 1 or Honors Math 8, when you first learned to graph systems of inequalities. Going all the way then through Math 2 or Honors Math 2, where you learned how to graph quadratics and linears that you've learned how to graph over the years, and exponentials and absolute values, and we're going to be putting all these together in this lesson. Okay, so there's not really much that's actually new in this lesson. It is very much a review lesson. If you want to have out your notes from the other day in class when we went over function families, that might be a good idea, because we are going to be utilizing those as we graph. Okay, so first things first, going back to that Math 1, Honors Math 8 idea of how do we graph a system of inequalities, you start by graphing your function, whatever that is, so your starting point, your vertex, finding your stretch, plotting that linear equation or quadratic or exponential or whatever it happens to be. Okay? And then you are going to look at the sign within your inequality. If you have a less than or a greater than, you then are going to use a dashed line. The reason we use a dashed line is because the points on that line are not part of the solution. For a point to lie on a function on a line means that they are things that make the function equal. Well, there's no equals in less than or greater than, and so we're going to use a dashed line to be able to visually show that there is no equals involved. However, if you see a less than or greater, or a less than or equal, or a greater than or equal, then you will use a solid line, because now that there's an equals, the points on the line are a part of the solution. And so, like I said, after you plot your points for your linear or quadratic or whatever you have, you will either connect with a dashed or a solid, depending on what the sign is. Okay? And then with an inequality, one important part that is easily forgotten is you do have to shade. It is part of graphing an inequality. That shaded region is a way of showing all the points that make the system of inequalities true. Okay? And so if we have a less than, then we're going to shade towards our smaller values, which for the most part is below our inequality. If we have a greater than, then we're going to shade towards the larger values. And you're going to shade dark or highlight, or however you prefer to show your shaded region, the parts of those two regions that overlap. Okay? And then I always recommend that you check a point, right? It's easy to accidentally shade the wrong way or to have graphed something funny or something like that. And so by checking a point or two, you make sure when I plug in those points, do I actually make my system of inequalities a true statement? Okay? And so we're going to demonstrate that here. So for this set of notes, we have 4 examples that we're going to walk through, and then like we did with the last lesson, we then are going to practice them some more in class, answer any questions you might have, that kind of thing. So as we go, make sure you are marking those questions now. Write them down now so you don't forget, right? So first up, we have graph the system of inequalities on the graph provided, and then if there's a solution, right, a shaded region that matches for both, then we're going to name 2 points in the solution set. Okay? And so first up, let's go ahead and take a look at this one. Which function family do we have with the y is greater than 2x plus 1? Okay, well that's a linear, and so if you are looking at your function family review there, we have our linear equation. Let's go ahead and turn this into its descriptive form. So I'm going to subtract the 1 over to the other side. Subtracting over the y. We can now pull out our starting point. Okay, remember we're making the 2 pieces 0, our moved origin. Okay, and so what would 0 out the x component? Well, that would be 0. And what about the y component? That would be 1. Okay, and then that's our starting point, 0, 1. And so then with a linear, we also need our slope. What is our slope in this case? Our slope is 2. So then we're going to move a slope of 2, up 2 over 1, up 2 over 1. And then you can keep going the other way as well if you would like. Okay. And then is this going to be a dashed line or a solid line? Okay, well that depends on what the sign is. Look at the sign does not have an equals, and so we are going to be a dashed line as I connect these. Okay. Next up we have this one. What type of function family do we have here? Okay, well with that squared, this is a quadratic, so then you're looking at your quadratic on your function family review. Let's go ahead and turn it into its descriptive form. I'm going to subtract that 3 over to the other side. Okay, so I can pull out my starting point. Again, zeroing the x component and the y component for our shifted origin. What would zero out my x component over here? That would be 0. What about my y? And that would be 3. And so 0, 1, 2, 3. And then our a, our shift in this particular case, is -1. So think about that. If I have a negative quadratic, which way am I going? Okay, my u therefore would be downwards facing u. And remember, with a quadratic, that a only happens one time. After that, each successive point changes its rate of change because this is a quadratic. If it bothers you to only have the 3, remember that you always have your tried and true friend, the XY t-chart. And so if it bothers you to only have those 3, you can plug in x equals 2. Well, what would y be at x equals 2? And you can plug it in here or here, it doesn't matter. When I plug in x equals 2, right, I get y is less than or equal to 1. I'm sorry, -1. 3 minus 4, right, 2 squared. So we're at -1. And then remember it mirrors on the other side. Or you could plug in -2 if you wanted to. And if you wanted to plug in 3 as well, you could. 3 minus 3 squared, or 3 minus 9, is -6. And so you could put that, oops, there. Okay, solid or dashed line? Okay, well there's an equals for this one, so this is solid. Okay. The piece that is easiest to forget with shading, or with graphing an inequality, is the shading. Okay, and so we need to remember to shade. It's part of graphing an inequality. Okay, and so here we have y is greater than my linear function here, which means I'm going to be shading above my linear function. In this one, y is less than my quadratic function, so I'm going to be shading below my quadratic function. Okay, well if I'm shading above my linear, that would be everything over here. If I'm shading below my quadratic, that's everything over here. Okay, what's the part that's overlapping? It would be this region right in here. This is all of the stuff that is above the linear, right, above the linear, but below the quadratic. And then naming 2 points in that set, which we are going to use to check. 1 point, and you can name any 2 points you want. 1 point in this set is 0, 2. And another point in this set is -1, 1. So those are what I'm going to name. And you can use them, like I said, to check that your region is correct. If I plug in x equals 0 and y equals 2, does that make both of these inequalities true? Well, if I plug in x equals 0 and y equals 2, I get 2 is greater than 2 times 0 plus 1, which means 2 is greater than 0 plus 1, which is 2 is greater than 1. And so you can plug it in to test since that's true. So far so good. What about this one? 2 is less than or equal to 3 minus 0 squared. So 2 is less than or equal to 3, which is true. And so since that point makes both of these true, I know I shaded the right region. Okay, number 2. Go ahead and graph this one. If at any point you would like to pause the video, try it on your own, feel free to do so. I'm going to keep working through the last three. Like I said, 4 problems total for this set of notes. Okay, first up, what do we have here? Well, that's an absolute value. Okay, turning it into its descriptive form, I've got nothing to add or subtract over the y, so it already is in its descriptive form. Okay, go ahead and identify what's your starting point or vertex. Okay, well, what would zero out the x component? That would be 1. What about the y component? That would be 0. So 1, 0 is right here. Okay, absolute value, we're looking at slope here of -2. If my slope is -2, what way does that mean my absolute value is facing? It means it's facing down, so we've got a downwards v here as we do our slope of -2. Down 2 over 1, down 2 over 1. Okay, solid or dashed? Okay, well, there's an equals. And so therefore, we have a solid line. Okay. Okay, next one. What do we have here? Okay, there's a squared, so we're looking at the quadratic on our function family review. Okay, let's turn it into descriptive form. We're going to subtract that 1 over to the other side. Okay, what's your starting point or your vertex? Okay, well, what zeroes out the x? That would be -1. What about the y? That would be 1. Okay, and then my a in this case, what's being multiplied out front here? Okay, that a is an a of 1, right? Okay, and so that means, remember, quadratics, it's a positive, so we're faced upwards. Only the first 2 points are that distance of 1 over 1. Everything after that changes. If you want, you can use a little XYT chart to plot the rest. I'll go ahead and plot 1 extra point for this one. If I plug in x equals 1, I get 1 plus 1, which is 2, squared is 4, plus 1 is 5. And so I'll go ahead and plot 1, 5 as well. And mirror that on the other side. Okay, dashed or solid? Okay, well, this one has no equals, so this one is dashed. Make sure you're keeping that U shape. Make sure it doesn't look like a V. V is absolute value. This is a quadratic. Okay? And then shaded region, are we shading above or below? Okay, well, take a look at your absolute value first. In this case, my shaded region is greater than my absolute value. So I'm going to be shading above the absolute value. So that'd be everything over here. Everything except for this little triangular piece, which is below the absolute value. What about the quadratic? Okay. Well, here y is less than my quadratic, so below my quadratic, so I'm shading all of this region in here, everything except for this little u piece, which is above my quadratic. And so what's their overlap? It'll be all of this region here. Okay. And then what are 2 points in that solution set? Well, you can name any 2 points you want. It does not matter. I notice the origin is in that solution set, so I'm going to go ahead and name 0, 0. And, you know, just for the fun of it, let's go out like 6, 5 or something like that. 6, 5 is also in that shaded region. And then again, you can use them to double check. If I plug in 0, 0, is 0 greater than or equal to -2 times 0 minus 1, absolute value of 0 minus 1? Well, that means 0 is greater than or equal to -2 times 1, because remember, absolute value makes things positive, so 0 minus 1 would be -1, absolute value would be +1. Is 0 greater than or equal to negative 2 times 1? Well, yeah, 0 is greater than or equal to negative 2. And then same thing here, 0 is less than 0 plus 1, quantity squared plus 1, which is 0 is less than 1 plus 1, which is 0 is less than 2. That is true. It makes both of them true, and so I know I shaded the right region. Okay, next up, number 3. What do we have here? Okay, well, this is a special case linear. So go ahead and look on your function family review. What does a y equals 2 line look like? Hopefully you identified that it is a horizontal line, right? It's going through y equals 2 here. It's saying that no matter what x is, y is 2. So when x is 1, y is 2. When x is 7 or whatever, y is 2. When x is negative 3, y is 2. And so that's why we get that horizontal line. And then one more time, why did I draw this in as a solid line again? Okay, because there's an equals here, right? If there's an equals, then it's a solid line. Okay, what do we have in this other function? Okay, this is an exponential. So now we're looking at the exponential on our function family review. Nothing to add or subtract over, so I'm already in descriptive form. Yay. And so go ahead and pull out your starting point. Okay, well, what zeroes out the x component? That would be 0. What about the y component? It would be also 0. And then on an exponential, where's my starting point again? What does that represent, I should say? On an exponential, remember that your starting point represents your asymptote. And so we have an asymptote here at 0, 0. Okay. We need 2 other points. Remember, you can use whichever 2 points you want. My recommendation is always to start with the x you've already found. Why not? When x is 0, what does y equal? And then I'm going to also plug in x equals 1. Okay, so plugging in 0, we have 3 to the 0, plugging 0 into my exponential here, which is 1. And plugging in 1, we have 3 to the 1, which is 3. So 0, 1 is one of our points, and 1, 3 is another. Okay? Solid or dashed? No equals. So this one is dashed. Okay, and then shaded region. Where are we shading? Y is greater than or equal to 2. Okay, well, this means that y is bigger than or above 2. So we're shading up here for the line, above the line. And then here, what about the exponential? Okay. Well, y is less than my exponential. Y is below my exponential. So we're doing everything that's below the exponential, which is all this region, not this little curved piece. This is above the exponential. But everything down here is below the exponential. Well, what's your overlapping region between your horizontal, greater than your horizontal, above your horizontal, but below your exponential? Okay. All of this region here. Okay? And then 2 points. What are 2 points in that region? I'm going to name 3, 3. And let's do 5, 4. I don't know. It doesn't matter. As long as it's in the shaded region, you can name it. And then again, I recommend using one or both. If you have time, why not check both? Better safe than sorry. plugging them in, making sure they actually make it true. So I'm going to plug in 3, 3. Is 3 greater than or equal to 2? Yep. And then 3, 3, is 3 less than 3 to the third? Or 3 less than 27? Yep. And so we're good to go. Okay, one more. And again, if you'd like to pause it and try it on your own, go ahead and do so. This one we've got 3 that we are graphing. So first up, x is less than 2. What's that? Okay, well, that's another special case. So look at your special cases. The x equals, looks like what? Okay, well, this would be a vertical line. Okay, and so we're going to 2. X equals 2 is right here. And again, that's saying no matter what y is, x is 2, right? So when y is 4, x is 2. When y is negative 3, x is 2. Right? And so we get that vertical line. Solid or dashed? Okay, no equals, so this one's dashed. Okay. Next up, what do we have here? Okay, that one's a linear. It's not in descriptive form yet, so let's go ahead and get it in descriptive form. Subtract this 2 over to the other side. Y minus 2 is less than or equal to negative x. Starting point. Okay, what zeroes out the x? 0. What zeroes out the y? 2. And so that's my starting point, 0, 2. Okay, what's your slope for this linear? My slope is negative 1. And so we're down 1 over 1, down 1 over 1. And if you want to, you can go back the other direction as well. Okay, solid or dashed? There's an equals, so this one is solid. Okay. Last but not least, what do we have here? Okay, this one is also linear. Turn it into its descriptive form. What are we doing? Adding the 3 over, which gives us our starting point. What's our starting point in this case? Whoops. Greater than or equal to, sorry. What's our starting point in this case? Okay, well, what zeroes out the x? 0. And the y? Negative 3. So my starting point is at 0, negative 3. And slope for this linear is 1/2. Okay, and so we're up 1 over 2, up 1 over 2. And then if you want to, you can go back the other way, down 1, left 2. Solid or dashed? Okay, well, this one's solid. There's an equals. Okay, now for our shaded region, the final piece here. We have 3 functions we have to consider. So let's start. I'm actually going to start with the bottom one for this one. I'm going to end with the x is less than 2. Okay, so starting with the bottom one. Where am I shading with relation to this function? Okay, well here my y is greater than my linear, so my y is going to be above my linear. And so this function here, it's going to be above that guy, so we're talking up here, right, above this line here. Okay, what about the second one? Okay, well here my y is less than my linear, so I'm shading below this linear. So we're shading down here somewhere. Okay, so I've already seen there's probably something having to do with this little triangle above this line but below this line. So something with that triangle. The reason I wanted to end with this one is x is less than 2. Well, that's a vertical line, meaning we can't be above or below that. And so pause here for a second and think about that. If you have a vertical line, which side do you think is above? And which side do you think is below? Or which side do you think is greater versus which side do you think is less? I actually think that's the easier way to consider it. Okay, well that's x equals 2. What's the number greater than 2? 3, 4, 5? Which side of x equals 2 is 3, 4, 5 on? It's on the right. Okay? The right, when I'm a vertical line, the right is the greater side, right? These are the bigger numbers. The further right I go, the bigger my number is. Okay? Versus the smaller I am, the further left I go, right? What's less than 2 would be, -5. Well, -5 is on the left over here. And so this one we're shading left of this line. Okay, well the only region that is above this bottom line but below this one, these two equations, and left of my vertical line is this. It's not a triangle anymore because I'm not going to go all the way to this point, right? If I go to this point, now I'm right of that vertical line. I'm greater than that vertical line. So it's a trapezoid. And then 2 points in that set. I notice the origin is there, so I'm going to name 0, 0. And let's say -3, -1. And again, you can always double check. Is 0 less than 2? Yep. So first inequality is good. 0, 0. Is 0 less than or equal to 2 minus 0? Yep. 0 is less than or equal to 2. That's true. So good to go. And is 0 greater than or equal to 1/2 times 0 minus 3, which is 0 greater than or equal to 0 minus 3, which is 0 greater than or equal to -3, which is also true. And so I shaded the right region.